Particle under constant velocity. Constant velocity, we'll call it V sub x, is equal to the formula for average velocity, which is your displacement over your change in time. If you recall, our displacement is a final position minus an initial position all over a change in time. Let's say we wanted to solve for our final position. I can multiply both sides by delta t, and I'm left with delta t multiplied by v sub x is equal to your final position minus your initial position. Let's go ahead and add the initial position to both sides. And I'm left with my initial position plus my constant velocity multiplied by a change in time is equal to my final position. I could also write it as my final position is equal to my initial position plus the quantity of my constant velocity multiplied by my change in time. This is a pretty popular formula that can be used if you have a constant velocity. Let's do an example. In this problem, we have a given for part A of a displacement of positive 20 meters, so 20 meters in the positive or right direction or up direction, whatever positive is defined as, a change in time of 4.0 seconds, and you are to find for part A what is that constant velocity. So there is a displacement given, there is a change in time given, and we are also told that there is a constant velocity. So after we figure out what it is we want to find, then we're going to look at what formulas we have. In this case, the formula we want to use for part A is constant velocity is equal to a displacement over a change in time. And the last thing I want to do then is plug in for a solution for part A. And my constant velocity then, just plugging in the numbers, is going to be 20 meters over 4.0 seconds. And that's going to equal 5.0 meters per second if I wanted my answer in two significant figures. Notice in this problem, I've written out what was given, what is it we want to define, what formula we were going to use to solve the problem, and lastly we plugged in our numbers to find our solution. A lot of times when we do problems, we will write out what I call a GFFS, and that will be showing your work in this class. So showing your work is writing out a given, a find, a formula, and a solution. And sometimes it's nice to put a box around your answer to show that that's where your solution is. Now for this particular problem, there is a part B. And for part B, it says if you have your constant velocity that you already found of 5.0 meters per second, let's rewrite this with the given. And our given is our constant velocity, again, is 5.0 meters per second. What if a person were to run, say 10 seconds, and they had a constant velocity of 5.0 meters per second? How far would they run if their initial position started at the starting point, which we may call 0 meters? So what are we going to find? We're going to find what is that final position. The formula that we're going to use for this is the one that we derived earlier. So x sub f is equal to x sub I plus your constant velocity multiplied by your change in time. And for solving, let's just plug in the numbers here real quick. So x sub I is 0 meters. My v sub x is 5.0 meters per second, and my time is 10 seconds. And so that gives me an answer of 50 meters. There's my answer there. Note I have my given, find, formula, and solution. Here is your practice. Thanks for watching.